Hello class, how are you doing? Unfortunately, due to the coronavirus, we must move all our teaching online, and I didn't find any other option to help my students other than do exactly what I do in classroom and post them online. And I'm sure there are many of you across the world that watching these videos, and I don't know, you might like it or you might do not like it, but I want to let you know that if you think these videos are helpful and I think I can help you in the future, shoot me an email and the topic you want me to create a video with, then I'll be glad to post the video you need. And at least in case if students need tutoring and they don't want to pay, maybe this one help them to succeed. As a student, sometimes you're going to say, I don't know any technique of integration. I don't know the power rules. I don't know chain rules. I don't know how to do integration by parts. I don't know partial fraction decomposition. And I was asked to integrate this integral. Please note in here that when you have an indefinite integral such as this, all you're trying to do, find the function that is derivative is this, a function. There are many functions. Therefore, this is called antiderivative. And this is x cubed over 3 plus c. That's the family of the function. Nothing here is required other than undo the rules of the derivative. What is the rule of the derivative? You multiplied, you subtract. Like if you have x squared, you want to take the derivative, you take the power, multiply it, and you subtract. Antiderivative said go backward. Subtraction become addition, multiplication become division. Therefore, if I give you 2x dx and I ask you find it, undo it, add to the power divided by the new power, and you get your x squared back. This is called antiderivative. There is no limit requires, no Riemann sum, but when it comes to this definite integral, this definite integral is born from a Riemann sum. A Riemann sum said take f of xi, mean this is the height of one of these rectangles. It could be the right corner, it could be the left corner, it could be the midpoint, times the delta x of that specific rectangles, because you have infinitely many of them sometime. This is the first one, second one, third one, and the fourth one, and the fifth one. I call it, if it's the fifth, I call this one the ith one. Ith one could be the first or the second or the third or the fourth. A number of rectangles go from 1 to infinity as far as the delta x approaches 0. Therefore, definite integral ties to the limit. Do you see? Definite integrals requires limit, but antiderivative doesn't require limit. Therefore, a student should know the difference between differentiation and also integration. Differentiation does require a limit. Definite integral does require a limit. But when I talk about antiderivative, I'm talking about indefinite integral, which I don't need any limit. And all I have to do, undo the rules of the derivative. Okay, you don't know any technique and you want to do that. You're going to go in here and say, I'm going to assume that function is not hard. You put x1, 1.5, 2, 2.5, 3, 3.5. I'm not over 3.5. You stop at 3. And from 1 to 3, you're going to have some function. And because this is a definite integral, you must guarantee that for every point between 1 and 3, this function is defined. And this has to be a positive quantity. Means the area under the curve has to be above the x-axis. Therefore, if this is 1 and 3, you're going to say, I'm going to divide it into a rectangle. Remember, you don't know any technique. And here you have to go start finding, this is 1, this is 1.5, this is 2, this is 2.5, this is 3. Put 1.5 in here, find that area, put 2 right for the function, find that area, put 2.5 in here, and find that area, and put 3 right here, and find that area. And you add all of them, you got the area, and you got the value. This is called numerical approach. But I'm sure some of you are going to say, well, I 100% with you. But when I go from 1 to 1.5, from 1 to 2, and 2 to 1.5, you are going to miss some part of the area. Therefore, what you're finding right here is not exact, it's approximation. I'm going to say all the integration are approximation. Even the derivative is approximation, because there is no way you can find the equation of a line, a tangent line, with 1 point. You have to make a secant line. And secant line means these 2 points cannot even get on top of each other. Therefore, tangent line still is a secant line, but because these 2 points are so close to each other, we assumed that's the 1 point. I mean, delta x is approaching 0. Does it ever become 0? No, because if delta x becomes 0, then the bottom becomes 0. You cannot divide by 0. But your issue was, you missing this part. I said, I know I'm missing. This is integration is approximation. Then you're going to say, approximation, but I don't want it to be too far off from reality. I want it at least be very close. I said, okay, that's another question. If you want it to be closed from 1 to 3, then let's do something else. Let's not do rectangles. Let's make this one a slant line. Let's make this one a slant line. Let's make this one a slant line, make this one a slant, and what you see is a trapezoid. And all the trapezoid have same base. And since it's a trapezoid, the area you're really missing is tiny, 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 tiny. Therefore, with 3 or 4 trapezoid, I probably can find exact. Then a student gonna ask me, but how do you find the area of a trapezoid? I'm gonna say, well, you studied geometry in 8th grade. Trapezoid is nothing except a rectangle which you go in the middle of that slant side. That's exactly the area of the trapezoid. Here I gain a piece, here I lost a piece. And what is the area of a rectangle? Base times height. The height is the same as the height of the rectangle. But the base of a rectangle, which is here, is the average of these two bases. Therefore, the base you are trying to find for the rectangle is the bottom base, the top base over 2. Therefore, the area is B times H. Okay? Let's tell me what is this. Let's assume this is the Y1. What is this? That's the Y2. These two rectangle trapezoid here, they share that side. Therefore, if this is Y1, this is Y2, Y2 belongs to this left side and the right side. And this is Y3. But Y3 to the left is for that trapezoid, to the right is for that trapezoid. And this is a Y4. To the left of Y4 is this trapezoid, to the right is this trapezoid. That's the Y5. This one only belongs to the left side, to the right side there is nothing. Therefore, remember, Y1 and Y5 only uses for one and only one trapezoid. But anything between them is going to be used for a trapezoid to his left, trapezoid to his right. And you know this one, all of them, the base is delta x. What is the area of a first trapezoid? Remember, you have to turn your page right now. These are your base right now. B1 plus B2 times divided by 2 times the height. Therefore, you have Y1 plus Y2 divided by 2, that's the height. That's the first one. What is the next one? Y2 plus Y3 divided by 2, a delta x. What is the next one? Y3 plus, remember, Y1 count Y once, but Y2 is twice. Y3 is twice. But I bet you Y4 is going to be count twice. How many trapezoids did I have? Uno, dos, tres, cuatro. 4 of them. 1, 2, 3, 4. Every one of them have delta x over 2 as a common factor. Then what is left? Y1 plus Y2. That's for the first trapezoid. Sum of the bases divided by 2 times the height. The next trapezoid. The next trapezoid. The next trapezoid. That's a simple version. But what is Y1 plus Y2 plus Y2? Is 2 of them. How many Y3? 2 of them. How many Y4? 2 of them. How many Y5? 1 of them. And this is delta x over 2. This is called a definite integral from A to B. As long as A to B, any number between A to B is part of the domain of your function, of some function of x dx, and that is equal to, okay, this is your starting point, this is your ending point. Then what is your delta x here? You have to say, well, this is B, this is A, this is the sum of all the delta x. That's the sum of all the delta x. How many trapezes you want to have? 3 divided by 3. How many you want to have? 4 divided by 4. How many do you want to have? 6 divided by 6. Somebody said, I don't know how many I want to have. I said, just put n. Therefore, this is your delta x. Your delta x is going to become b minus a. This is exactly the top limit over the bottom, minus the bottom, over a 2. Where did 2 come from? You average the bases times y1 plus, somebody said, can I call this one y0? It doesn't matter if you start from 0, which your I becomes 0. Somebody said, oh, when my I is 0, when the graph is started from 0, Therefore, this is called the y at x equal to 0, the y at x equal to 0.5, the y at x equal to 1, the y at x equal to 1.5, y1, two of them, because the y1 is going to count twice, two of them, plus dot, 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 plus 2 times y, n minus 1, that's 1 before the last, 1 at the end. That is the formula for finding the definite integral using trapezoid rules numerically. Okay, I'm going to do a simple problem. I know you know how to integrate it. I know you're going to complain, and I'm going to put x squared from 1 to 2 dx, and this is x cubed over 3 from 1 to 2, and that become 8/3 minus 1/3. The answer is 7/3. I want to use trapezoid rules and see if my trapezoid rules is, this is pretty much, this is not still exact because I use the limit at delta x approaches 0. I cannot make my delta x 0, but this is pretty much like exact. I'm going to use trapezoid rules. My x is 1 to the 2. That's the middle of it. That's the middle of the first half. That's the middle of the second half. I'm going to do 4 trapezoid. That's it. No more. Then what is x squared dx from 1 to 2? Is b minus a divided by n. That should be n, not 2, because I'm dividing to the n rig, 2n. I forgot that. I'm sorry. That 2 was for the base, but I have to divide it with my what? My delta x is b minus a over n. That's only my delta x. I made a mistake here. My delta x is b minus a over n. But the formula for the area was y1 plus y2 over 2 times delta x. And if I substitute delta x by b minus a over n, the bottom becomes 2n. Here I needed 2n. I made a mistake. I'm sorry. Then let me write the formula for trapezoid rule. B minus a over 2n y0 plus 2y1 plus dot 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 plus 2y n minus 1 plus yn. I forgot that 2n and I'm sorry. Okay. What is my b? 2. What is my a? 1. How many trapezoid I'm going to have? 4. But don't forget, you take the average of the bases. That's the 2n. Okay, I need y when x is 1, 2y when x is 1.25, 1.25, and I need 2y when x is 1.5, I need 2y when x is 1.75, and I need 1y when x is 2. That becomes 1 over 8. Okay, x is 1. And that's my function. My function f of x is equal to x squared. When x is 1, you have 1. And 2. 1.25. 1.25 squared. 1.25, why do I square it? 1.25 squared. 1.25 squared is 1.25 5625 plus 2. 1.5 square is 2.25. 1.75 squared, 3.0625. 2 squared is 4. 1/8. And I'm trying to see if I can, you can see the calculator. Okay, can you, okay, yeah, right now you can see the calculator. Here I had a 1. I had a 1 plus 2 times 1 point. Here you can easily put in the calculator 1.25 square, see, very easily, plus 2 times 1.5 squared plus 2 times 1.75 squared plus 1 times 2 squared. All of them is 18.75. See, that's 18.75. But if I did that 1875 divided by 8, I got 2.34, only with 4 trapezoid. But when I did it by technique, I got 7 divided by 3. What is it? If I only subtract this one, what is the difference? See, only 4 trapezoid. What happened if I made it 5? What happened if I made it 6? It becomes exactly the same. Therefore, trapezoid is very helpful to do it numerically. Therefore, in the next video, I'm going to do some examples of the trapezoid rules. Do you have to memorize the formula for trapezoid rules? You don't have to, because you have to know y1 plus 2y2 plus 3y3 plus 2, y1 plus 2y1. Repeat it, I'm not looking at anything. y1, my eyes is closed. y1 plus 2y2 plus 2y3 plus 2y4 plus 2y5 plus 1y6. All over 2 times delta x. And what is your delta x? b minus a over n. Because you have to take your b minus a and divided it in so many trapezoid. Thank you and have a great day.